Hey guys, welcome to Objective 2.6, Manage the Object Lifecycle. In this objective, we're going to be looking at managing unmanaged resources, implementing and using the iDisposable interface, and manage the finalization and garbage collection. So if you watch these videos in order, you'll notice that I skipped Objective 2.5 for now. If people want, I will go back and do it, but basically the reason why I'm skipping it is because it's really just something that you should just read over, and it's just something that you should just take a look at. Basically, it covers attributes, attributes, reflection, and generating code at runtime. So you can look at that if you want, and if you guys really want, I will make a video on it. But just look at if you have the book, just look at the examples in the book. And I mean, the book doesn't even go into it that much. But yeah. So in this lesson, we're going to be talking about basically garbage collection. And basically, if you're coming from a language like C++ or something, some kind of unmanaged language, you'll know that in like a language like C++, you have to handle memory yourself. Basically, C++ does not have a garbage collector, so when you allocate things and that are getting allocated on the heap, you have to actually manage that yourself. You have to release that memory, and if you don't actually free that memory, you can get a thing called a memory leak. So in language like C++, the memory management, it's all up to the programmer. They have to manage memory, and obviously there are benefits to that. Rather than having a garbage collector like C# does. So C# is a managed language that uses a garbage collector, and the garbage collector will free our resources for us, as long as we're using managed tools. As long as we're using managed objects, the garbage collector will free our resources for us, so we don't have to deal with that, or it'll free our memory. So we'll talk about that in a second. But there will be times that we were dealing with unmanaged resources, and there are examples of that. And the book gives like a database connection, file handles, things like that. Sometimes we'll be dealing with unmanaged resources, and it's good to have a basic understanding of the garbage collection process and implementing some kind of like finalizers and things like that. So we're going to look at that in this lesson. So before we dive into everything, let's first try to understand garbage collection, the basic process that happens inside of C#. And I'm just going to be going over what the book says. So let's start off with, I've actually talked about this in some videos. I have a video in my advanced C# section that goes over value types versus reference types. But basically, there are two places in memory that we use. We have what is called the stack and the heap. Now, each of these are very complicated topics. And where things get allocated on the stack and the heap, it all depends on what you're doing. Most of the time when you're allocating things in C# using the new keyword, that means that we're allocating memory onto the heap. But whenever we have things on the heap, we also have a variable, some kind of value type variable that's holding the actual reference to that object on the heap. So that is being stored on the stack. So basically, the good way to think of it is when we define variables inside a function like int x equals 5, this variable right here, it's a value type variable. This is being completely stored on the stack. It's creating an integer on the stack, getting a memory location, etc., and assigning the value 5 into that slot. But when we have some kind of reference type, like random r equals new random, this is actually creating and allocating memory on the heap using this new keyword, and then we're storing that reference into the random r variable, which this is being stored on the stack. Variables that are stored in the stack are released at the end of a function. That's why we have this thing called a call stack that you can look and see how you can use the call stack to see what happens. And one variable is being popped off of it and pushed onto it. But basically, at the end, when main exits, int x and random r will be gone. And basically, what happens in this scenario is when main ends, if the program didn't actually terminate, which it does, let's say if this was just a random function that I had defined, once the main function ends, int x would be gone. That would be popped off the stack, and that wouldn't exist anymore. It's a local variable. That's how it happened. It's considered a local variable because of this concept that it's being pushed onto the stack, and once it ends, it's going to be popped off, and then the memory is gone. But this is a little bit more interesting with this reference type. Yes, when we leave main or whatever function we're in, the R variable will be popped off the stack. So that variable will be gone. There's two separate variables. That memory for the stack will be released automatically, instantly. But memory for the actual object where that's stored, the actual random class, that will still be allocated on the heap. That will not be touched until the garbage collector comes in and releases that. So that will still be there. The only thing that we just don't have access to it anymore because we lost our reference that is pointing to it. So we don't have access to it anymore, but it still exists until the garbage collector runs, which it's not going to... The garbage collector doesn't run that often because of the criteria. Like, for example, the garbage collector will not run while we still have available memory to use, and things like that. And even when it runs, if there's a reference held to something on the heap, it won't be released. And we'll talk about that here in a second. The book goes into that. So if I was in like a language like C++ and I used the new keyword to allocate something on the heap in C++, when we go out of scope and if we lost that reference to something, we would essentially be screwed. We would have a memory leak. We would have no variable that's pointing to this memory or has access to this memory location on the heap, and nothing is going to clean it up. It's essentially, nothing knows that it exists anymore on that heap, so we're going to have a problem. So to fix that in C++, we have to release memory. So if this was C++ before, my function ended, I would have to say delete R or something like that. That would free my resources on that object. But like I said, in C#, it is a managed language, which that's a .NET term. But basically, we can say it's a managed language, and we have a garbage collector. Java, similar to this, also has a garbage collector. So in Java, we don't have to worry about memory cleaning. We don't have to worry about cleaning up memory. In languages like C, obviously, we have to do it. I'm pretty sure. I'm not an Objective-C programmer, but I'm pretty sure you have to clean up your resources in Objective-C also. It's like C++. Okay. So now let's just the book talks about it a little bit, so let's go ahead and slightly talk about how the garbage collector works. So the garbage collector uses this pattern called the mark and compact algorithm. So basically the garbage collector goes through the heap, and it looks for items that are still being referenced by an item. And that item could be a method parameter, a local variable, a static field. So it basically goes through the heap, and it looks for items that are still being referenced. And what that means is, it's looking for something. All right, here's a new random. It's looking, so this part is on the heap. It's looking for somewhere that, it has a variable R that's holding that reference to this memory. It's looking for that. So once I pop out and leave this function, whatever function I'm in, we lose the random R variable because it's going to be popped off the stack, but we stole the memory on the heap. So the garbage collector would come in and it's looking for that. It's marking the things that do still have references. So because once we left this, it wouldn't be marked. So then what happens is, then we enter the compact stage. And the compact stage, basically all that's doing is it's bringing all the items on the heap that were marked, it compacts them together, puts them all together, and then all the other spots that we had that are not marked anymore will be freed. So the garbage collector has to also, while it's doing this, make sure that no state is changing. So because of that, all threads are frozen while garbage collection is going on. The garbage collector also has to make sure, after doing some moving around, that everything is hooked up properly and everything, because when memory is being moved around, the variables that are pointing to those or referencing those have to now be updated with the new memory location that the memory got moved to, because everything's based off of memory locations. So obviously this is a big performance impact, and because of that, the garbage collector will only clean at certain times. If there is no memory on the heap to construct any new objects, that is one time that the garbage collector would kick in if we need to make some room. It would also kick in if Windows, the operating system, actually signaled that it's low on memory. Then that's another way it could kick in. So basically, when the garbage collector actually starts running, the garbage collector only cleans up items that are considered generation 0 items. So basically what happens is, as we're going through the marking compact stages, when items are getting marked, if they are still alive, they're getting promoted in generation. And the assumption, their generation level goes higher. And the assumption behind that is that if the reference is still alive when the garbage collector is running, is that those objects are most likely going to stay around for a long time, or a decent amount of time. And that's because items that are removed, it assumes that the items in generation 0 are just the items that were created maybe for a couple of uses, and that's it. So they only have a small amount of time that they were really living. So that's why, I don't know, what else should I say? Yeah. So as items live, they get promoted in generations. So the collector's only going to remove at generation 0, unless the garbage collector cannot free enough memory by just cleaning generation 0. So then, depending on that, it will continue up the generations. But most likely, generation 0 will be enough for garbage collecting. So if we were only dealing with managed resources all the time, this would be fine. Our garbage collector would do an awesome job, and that's all we would need. But there are times that we are dealing with unmanaged resources, and once again, the book gives examples like network connection, file handles, Windows handles, and database connections. So those kind of items need to be closed forcibly by doing some kind of function call on them. We need to clean those up, and if we don't, we can get errors because of that. Like, for example, this file is still in use, the book says. So because of this, C# offers this concept of a finalizer, or the concept of finalization. And basically, this allows us to clean up anything prior to being garbage collected. This is sort of similar to the C++ destructor, but the difference is that a C# finalizer, we don't know when it will be called. Now, I'm going to modify that here in a little bit when we look at an example, but we don't know when it's going to be called. But a C++ destructor, we know exactly when it will be called, either when we're freeing resources or something gets popped off the stack. The finalizer, for the most part, is only called when the garbage collector determines that the object is ready to be cleaned up, like we talked about before, using the mark and compact algorithms. So to create a finalizer, we use the tilde thing, just like the tilde operator or character, just like we do in C++. So let's go ahead and create a class to mess with. Call a class some type, and let's just make this finalizer that it's talking about. So whatever the tilde key, and then just like we're creating a constructor, and if you're from C++, it's the same thing as creating a destructor. So this is our finalizer right here. So inside this finalizer, if our class was using unmanaged resources, this is where we would clean it up. So once some type, once some type is collected by the garbage collector or something like that, we can free up the unmanaged resources in our finalizer. So an example of this that we're going to look at is using the file class, creating a file, and basically, if in order to delete a file, Um, First, everything has to be freed and cleaned up before we can delete a file. So let's go ahead and take a look at this. So let's go ahead and create. I guess we can create a function in some type called public void create file. And inside of this function, we're just going to say stream writer stream equals file dot create text, and we're going to call it temp.dat. Then we're going to say stream.write, and we're going to write in some data. And then, while it's still open, we're going to say file.delete, and we're going to attempt to delete our temp.data. And we're going to try to see what happens. So inside the main function, I'm just going to say some type t equals new type and t.create file. So let's go ahead and run this and see what happens. Wait, hold on. Okay, I called it data. Okay, let's try that. Okay, there we go. So because we didn't clean up any resources, we're getting an exception. So let's go ahead and see if we can do something to maybe fix this. So as you know, the class for our file, the finalizer on it, which cleans up resources, will only be called when the garbage collector finds that it is ready to be cleaned up. So to do this, we can actually force the garbage collector to run by saying gc.collect. And this will actually force the garbage collector. We can explicitly force it to run. And now let's see what happens with this. So it looks like we're still getting the error. And the reason why we're getting an error still is because we're running in debug mode. The book actually talks about this if you want to look at it. Basically, let's go ahead and try to switch to release mode. Let's recompile this. And let's run this again. And as you can see, now when we run it, we have no problem. Basically, what's happening is, in debug mode, the compiler makes sure that the reference isn't garbage collected until the end of the method. So by running in release mode, we can fix that problem. So when the garbage collected, when we call gc.collect, we can force the garbage collector to run. Then the finalize function will be ran. And then once the finalizer runs, it's going to release any resources that's holding a file handle to our temp.dat file. So although that this works, it's not the best solution for this because it's not ideal to depend on the garbage collector to run the finalizer at some point in order for us to close our file. So instead of doing that, we should actually close the files ourselves. So to explicitly free unmanaged resources, C# allows us to implement or use this idea of iDisposable interface. So the iDisposable interface implements one method called dispose, and the job of the dispose function is to free any unmanaged resources immediately. So if we take a look at the stream class and we say stream.dispose, because StreamWriter implements iDisposable, it has a dispose function. Now let's go ahead and run that, and it still works. So we're forcing the cleanup by calling stream.dispose instead of waiting for the garbage collector to call its finalizer. But here's the question: what if an exception got thrown before stream.dispose could be called? What would happen in that situation? So there's a way that we can make sure our resources are always cleaned up. So one way to do this would be to wrap our iDisposable in a try finally statement, which basically means that if we put anything in a try, and the finally will guarantee that no matter what happens in the try, the finally part will run. But because this is so common, C# offers a statement, or the using statement.
So with any type that implements iDisposable, we can use a using statement around it, and the using statement just makes sure that dispose is called at the end of the statement for cleanup.
So if you want to implement that into here and see what it looks like, we would just wrap this around using the using keyword like this. Now, if we removed the stream.dispose, since we don't need that anymore, and we ran this, once again, we have no problem. So the using, we use a using statement like this, and then once the using statement ends, which right here, dispose is called automatically. So it is a good habit to get into when you're using any kind of type or resource that implements iDisposable to wrap it in a using statement. So far we looked at we looked at a finalizer and implementing this iDisposable interface slightly. And basically iDisposable allows us to forcefully say, okay, I want to clean resources on this, whereas the finalizer kicks in if the garbage collector is running and it finds that this needs to be cleaned up and it never got called disposed on. Then the finalizer will run as backup. So this is an example from the book that basically it implements a finalizer and the iDisposable interface. It implements them both, and the code, the actual creating the buffer and using the integer or the int pointer for the unmanaged buffer is not really important. It's allocating memory and things like that. But the most important thing to see out of this is the example from the book is we implement the finalizer. Here we also implement a close function, which close in this case is the same thing as dispose. Close just calls dispose. So if you want to just type out close, you could do that also. But the real dispose function is right here. This is the meat of it, which takes in a bool value called disposing. Basically, in this side of this, we clean up our unmanaged resources right here, and then we say if disposing is true, then we'll close the stream also. So let's take a look at what is going on. So basically, what happens is if the finalizer is called, that means we didn't explicitly do the cleanup. If the finalizer is called, it calls dispose. So this means the garbage collector is running right now. It calls dispose, passing in false. So that means that it's only going to free the unmanaged resources that we created, but it's not going to close the stream. And the reason why it's not closing the stream is because inside of the stream class, it implements, not the stream class, the file stream class, it implements a finalizer. Maybe we can actually see that if I go to definition. I don't know. We can't see it. Maybe it's wait. Maybe it's. I don't know. It implements a finalizer. I don't know. That's besides the point. It implements a finalizer. So basically, the garbage collector, because it's running and it executed this class's finalizer, my unmanaged wrappers finalizer. That means that the finalizer for the file stream class, or this stream right here, that's going to be executed also. So there's no need for us to explicitly call close on it because the finalizer is going to be running and cleaning that up anyway. So we don't need to call close. Now, however, if we are forcefully closing it by either calling close or dispose, maybe it's inside of a using statement, who knows, it calls dispose passing in true. So by passing in true, it's going to free the unmanaged resources, and it's also going to call stream.close or stream.dispose if we wanted to. And that will clean up that because the finalizer isn't running at this point. Now what happens here is basically we are calling system.gc suppress finalize this when we forcefully dispose something. And basically what that means is that we are, oops, I hit the back. Basically what that means is that we are saying to the garbage collector, if you kick in, do not worry about this. I'm suppressing the finalizer. Do not call the finalizer on this. That's what the suppress finalize is saying. So by calling suppress finalize, we are removing the object from the finalization list that the garbage collector is keeping track of. So now we don't have to worry about the garbage collector coming in and calling the finalize on this, because then we would just have problems because we're forcefully closing it. So this just makes sure it's in the clear for the garbage collector. So that is the difference between actually calling dispose and having the finalizer called. And in the book, it has a little subsection for an exam tip. And the exam tip reads, which is basically what I was saying, it's important to know the difference between implementing iDisposable and a finalizer. Both clean up your object, but a finalizer is called by the garbage collector, and the dispose method can be called from code. So yes, the dispose function is called by us, maybe explicitly, maybe using a using statement, while the finalizer is called by the garbage collector. And if we do forcefully call dispose, we have to make sure we suppress the finalizer so that that won't run when the garbage collector comes through. Okay, so that is it for this lesson. Now, I talked a lot about garbage collection and things like that, all from the book. And, I think the most important takeaway from this lesson is exactly what I've been saying. Really, I think the most important thing to know for the exam is know the difference between, when this stuff applies, when we're using unmanaged resources. But know really the difference between a finalizer and implementing iDisposable and having an explicit disposable function. Basically, by implementing iDisposable, that just allows us to use the using wrapper of a using statement around that to call the dispose automatically. But basically, by calling the dispose, what's the difference between call and dispose, and what's the difference between that and having the garbage collector call the finalizer, which does it automatically. Yes, so that is it for this. If you have any questions, be sure to let me know in the comments, and stay tuned for next video, which I think, let's see, it is on strings. We're talking about manipulating strings, searching strings, enumerating strings, and formatting strings. Okay, that's it for now.